Independent events. Two events are said to be independent if the occurrence or non-occurrence of one event does not affect the occurrence or non-occurrence of other events. Yeah. Let us consider an example. A bag contains 6 white and 3 red balls. Two balls are drawn one after the another. Now, two events are defined as one is event A is getting a white ball in the first draw. B. Another event B is getting a red ball in the second draw. First problem. Ball is not replaced after the first draw. Then what is the probability of event B? Probability of B given A, conditional probability. Third bit is probability of B given A bar. Second problem. Ball is replaced back after the first draw. In this also again, we'll try to calculate what is probability of B, probability of B given A, and probability of B given A bar. In the first problem, ball is not replaced after the first draw. Then to calculate probability of the event B, that is getting a red ball in the second draw, we'll be having two cases. One case is in the first draw, you may have a white ball or you may have a red ball. In the first draw, if it is a white ball is drawn, then it will be 6/9 into getting a red ball in the second draw is 3/8 because total number of balls is 8 because the ball is not replaced after the first draw. R plus, that is second case. Now instead of white ball, red ball also can be drawn in the first draw. That means 3/9 into 2/8 because the number of red balls will be now only 2. So the value will be 1/3. Now probability of B given A means A is occur, means you have taken a white ball in the first draw. Then what is the probability of getting a red ball in the second draw? Now red balls will be 3, total number of balls will be 8. Now 3/8 value is greater than 1/3, that is probability of B given A is greater than probability of B. Probability of B given A bar, that means A is not occur. When A is not occur means what? You have not taken a white ball in the first draw, means you have taken a red ball in the first draw. That means number of red balls now after the ball is not replaced. So it will be 2/8, which is 1/4. This 1/4 is less than 1/3. So probability of B given A bar is less than probability of B. That means here the probability of B given A is not equal to the probability of B. Also probability of B given A bar is not equal to the probability of B. So here the events are said to be dependent events. Now if I consider the second problem, ball is replaced back after the first draw. Then probability of B. Now here it will be 6/9 into 3/9 plus 3/9 into 3/9 because the ball is replaced back. So the denominator will be total number of balls will be always 8. So the value will be 1/3. Next probability of B given A. It will be 3/9 which is same as 1/3. That is same as again probability of B. Next probability of B given A bar is also 1/3 which is equal to probability of B. So here whether the event A is occur or non-occur, probability of B given A and probability of B given A bar is equal to the probability of B. So here the events are said to be independent events. That is, when the events are independent, we can write as probability of B given A equal to probability of B, or probability of B given A bar is also equal to probability of B. By using conditional probability definition, probability of B given A as probability of B intersection A upon probability of A equal to probability of B. That means probability of B intersection A equal to probability of A into probability of B. So if A and B are independent events, then probability of B given A, we can write as probability of B. Also probability of B given A bar equal to probability of B. Now, from conditional probability definition, so we can write as probability of A intersection B equal to probability of A into probability of B. And here probability of B intersection A bar equal to probability of B into probability of A bar. Now, suppose if A and B are independent events, that is probability of A intersection B equal to probability of A into probability of B. Then we using this, how to prove that the event A and B bar are also independent, A bar and B are independent, A bar and B bar are also independent. That means to prove the first one, we have to prove that probability of A intersection B bar equal to probability of A into probability of B bar we have to prove. Now here we have to prove that probability of A bar intersection B equal to probability of A bar into probability of B. Here probability of A bar intersection B bar we have to prove it as probability of A bar into probability of B bar. So let us take probability of A intersection B bar. Now if you observe the Venn diagram, A intersection B bar region is only A. That means this is same as probability of A minus probability of A intersection B. Now probability of A intersection B is same as probability of A into probability of B. So probability of A is common. Probability of A into 1 minus probability of B, which is same as probability of A into probability of B bar. So exactly in the same manner, we can draw the Venn diagram for this A bar intersection B, and you can prove it as probability of A bar into probability of B, as well as probability of A bar intersection B bar as probability of A bar into probability of B bar. So what about pairwise independent event and mutually independent event? A set of events A1 to AN are said to be pairwise independent if probability of AI intersection AJ must be equal to probability of AI into probability of AJ, I not equal to J, and I and J are from 1 to N. Now, because we are taking two events at a time, so the number of conditions in the above to satisfy pairwise independent is NC2, which is n into n minus 1 by 2. Mutually independent events. The events A1 to AN are said to be mutually independent if probability of AI intersection AJ must be equal to probability of AI into probability of AJ, not only for 2, it should be satisfied for 3 events, 4 events, and so on for n events. Now, the number of conditions in the above, that is number of conditions for mutually independent events, is NC2 plus NC3 plus NC4 and so on NCn, which is same as in the total sum of binomial coefficients is 2 power n. In the two terms are missing, which is NC0 and NC1. So 2 power n minus 1. So if A, comma B and C are independent events, then probability of occurrence of at least one of the event is probability of A and B and C, which is same as 1 minus probability of A and B and C whole complement by De Morgan's probability 1 minus probability of A bar intersection B bar intersection C bar. Now because A, B, C are independent, their complements are also independent. So we can write as 1 minus probability of A bar, probability of B bar, probability of C bar. And this can be extended for n events also.
Sir, if 1 out of 1,000 chances if he wins, then it is not negligible.
It will be